right, looks like my recording cut off right in the middle of that problem. So going back to the storm, then stopped for 2 hours. That's where you have a zero slope. It is just steady at time passes, but the amount of snow does not increase. So then we come over to the next section. Started again at a constant rate of 2 inches per hour for the next 6 hours. Okay, so 6 hours is going to pass. So you think about your starting here at hour 6, 6 hours from 6 hours is 12 hours. So the hours is going to go over to 12, and it's going up 2 inches per hour. 6 hours times 2 inches is 12. So you're going to increase 12 inches of snow. So you're going from 6 inches of snow up another 12 that ends up being 18. So 6 plus 12 is 18. That's how you end up with a final location of 12 hours since the storm began and a total of 18 inches of snow. So if you graph that, so it talks about the rate of change. Notice you could have found the rate of change by looking at the 2 points and doing your y2 take away y1 over x2 take away x1, which would give you that same rate of change. So like I said in the last problem, there's lots of different ways to go about collecting data and creating graphs. You could have calculated the rate of change and then focused on the slope. You could have just worked through each section of it. Both work. And we'll continue to do more problems like this in class tomorrow so that we can see more examples. All right, let's look at another section. We have a word problem. Go ahead and read through this one, pause, and then I will break it down step by step. When we look at this scenario, the first thing that we should notice is that it's talking about a constant rate. So we have to think to ourselves, what is a rate? A rate, okay, can mean lots of different things. It all means the same thing, but it can be expressed differently. The rate can be the slope, okay, which is m. How do you find slope? It's the change in y over the change in x. How do you break that down? y2 take away y1 over x2 take away x1. We're going to think about it as the rise over the run. Very important to unpack this. So when we see this as a graph, it looks like this. Okay, when we looked at this problem where it talked about the first snowfall fell at a constant rate, so it constantly went up. Then it talked about it stopped snowing. So there is the stop snowing portion. And then the second one, it also snowed again, which when it starts snowing, that means that your graph is going to go up. So first it snowed, it stopped. That meant it was at a constant stop, so a zero slope, and then increased again. So you went up again. What is the rate of snowfall during this? What is the rate? It was snowing during the second snowfall. So we had to identify on the graph where the second snowfall was. So we had to use our words to understand first snowfall, stopped snowing, second snowfall. Then we can find our rate by using either rise over run, change in y, over change in x. Either way works. So let's look at this. So when we go through it, we can mark this up. We can do our rise over our run. So think about it. Here's your run. Here's your rise. Rise over run. I can look at those coordinates as 20, 9. And this second coordinate is 11, 6. So you can put your rise over your run by counting 1, 2, 3, 4, 5, 6, 7, 8, 9. So your run was 9. Your rise is 1, 2, 3. So your rise over your run is 3 over 9, which simplifies down to 1/3. What's that mean? It means that you had 1 inch of snow on the ground over 3 hour time. So that is your rate of change. You could have also taken the coordinates and did 20 take away 11 as your x's and your y's. 9 take away 6. Get the same thing. So remember, you can calculate your rate by using either your rise over your run, by drawing in that triangle, or using your coordinates and simplifying, so that you find that the rate of the snow was falling was 1 inch over 3 hours.